everyone. Uh, Once again, this is Professor Roger Flores of the Department of Electrical Engineering of Central Mindanao University, your professor of the subject EE30, the Electrical Engineering Utilities. Okay, so today we are going to discuss Chapter 2 of our subject, Building Electrical Materials and Equipment. So we will be talking about materials here that even facilities to produce, to generate power or electrical energy, and the materials, the devices that will transmit and for utilization of the power systems or the energy that we are going to produce here. We have this 2.9 equipment protection. So to protect our equipment, unang-una, so we have this ground fault protection, no? So basically designed to detect and rapidly interrupt low-level equipment or ground fault. Operates on the same principle as GFCI or FCI, okay, ground fault protection. By monitoring the current drawn through the conductors of an electric circuit. So we have that ground fault protection for our equipment. So current transformer, dapat lagyan natin yan. Particular type of sensing transformer, it encircles the conductors in the switchboard or panel board. Produces a low current output signal if all current flowing to the load does not return to the source through the phase of neutral conductors. So lagyan natin ng yung klaseng ground fault system protection. Okay, so the low current output is sensed by a ground fault relay with adjustable sensitivity and time delay settings. When the signal above the sensitivity setting persists beyond the time delay setting, the relay operates to open the switch or the circuit breaker. So power surge, a sudden increase in electrical current for voltage that is very short in duration. Power surge yan. The said increase may be caused by lightning strike or by a sudden power spike. Okay, so caused by a problem in the utility transmission and generating system. And it may damage sensitive equipment such as computers, televisions, and any other machines. Surge rating, measure of the level of surge that can speedy or surge protection device can withstand. Okay, so manufacturers specify the surge ratings of this speedy. An electrical service that prevents power surge from reaching electric and electronic equipment or another devices. Okay, surge protection device, SPD. So ito po, marami tayong mga surge protection. Go over with this one. Mayroon pa nga tayong metal oxide varistor, MOV, to surge protection also. Semiconductor device used mainly on AC power applications with surge ratings ranging from a few hundred to many thousands of amperes. Mayroon po din tayong gas discharge tubes. Okay, so protection component with a surge rating of several thousand amps. Okay, so these are some of the devices that will determine and protect and sense the surge current. Mayroon din tayong Zener diode, secondary surge protection component used for accurate clamping of surge voltage. It has a quicker response time than the GDTs and provides more accurate clamping voltage than in MOVs. Next is hybrid circuit. Ito po, combination na po ng mga component na sinabi natin kanina. So we have to protect this circuit comprising different types of surge protection components, taking advantage of its component strengths, and hybrid may combine the high surge capability of the GDT with accurate voltage clamping or surge diodes. Okay, so we have this inrush current or input surge current. So ano po ba itong inrush current or input surge current? It refers to the peak instantaneous current measured in amperes. No? Peak instantaneous current drawn by an electrical appliance or piece of equipment. Okay, so example ng inrush current is yung power supplies, AC motors, lamps, and lighting ballast first turned on. So dito may problema tayo pag we have this inrush current. It will damage our system. It should be protected. So current can be also be reduced by inrush current limiter, which protects the circuits that encounter high inrush loads up to 30 times the rated current for the half cycle of 60 hertz. No? Eliminate nuisance tripping also. Many techniques are used to limit inrush current. So, negative temperature coefficient NTC thermistors used inrush current limiter to power supplies and the motor. Thermistor also, no? It will thermally sensitive resistor with a resistance that changes significantly unpredictably due to temperature change. So, thermistor yung ginagamit, kaya nga thermistor, thermal. So, equipment is first turned on, and NTC thermistor is cold, and its resistance is high, limiting current flow. So, we have those NTC. Okay, so we have to protect also our lightning against lightning, no? So lightning discharge have been measured from 2,000 and up to 200,000. It is just what we call this one, an approximate value of the lightning, but nobody can measure this value, no? With rise times to peak current of less than 10 microseconds. Okay, as a result, lightning causes more damages and injuries. Okay. Deaths each year than tornadoes, hurricanes, or floods. Okay, so maraming biktima dito sa lightning rather than these tornadoes and hurricanes in other countries or floods here in the Philippines. Lightning discharge been measured from ayun, with rise to peak more than 10 tornadoes. Ayun. Yan. So, Benjamin Franklin first suggested protecting buildings and other structures from the effects of direct lightning strikes by the use of protective conductors. So his theory stated that lightning protection must provide a direct path for the lightning bolt to follow to the ground, and it must prevent destruction, injury, or death as the current travels that path. Okay, so we have these vertical lightning rods. Okay, some cold air terminals are placed at the top of the protected structure. These lightning rods have equally spaced a maximum of 20 feet apart from the structure's high points. Okay, so a network of conductive copper or aluminum tape. So yun po yung ginagamit natin, no, na magiging lightning rods, no, that is positioned vertically to connect to the ground. So instead na doon yan tatama sa building natin, doon yan tatama sa mga vertical electrical rods, no? Electric rods. Okay. So we have this impedance, surge protection devices minimized. Ayun. So equipment for hazardous locations. So talking about hazardous location here, it's a hazardous location such as gasoline station, paint spray booth, both or factory explosion proof or explosion resistant equipment. You should have to protect this one. So hazardous location when fire or explosion hazard may exist because of flammable gases or vapors, flammable liquids, combustible dust, or quickly ignited fibers. So just try to protect against these hazard locations. So types of hazardous locations, we have this class and division or by zone. So, mayroon tayo dyan sa Philippine Electrical Code. In-specify yan. Okay, yung mga hazardous locations. Okay. So, equipment for hazardous locations. Explosion resistant equipment designed to prevent the ignition of explosive or flammable materials. Okay, so mayroon po tayo dito. Marami. Examples, nationally recognized testing laboratories. So, international pa yung iba, makaramihan dito sa kanila lang, sa kanilang country. I think we finished discussing everything here, this chapter 2. So, if you learn many things or something about this, please, what you call this one, subscribe my YouTube channel so that you will be able to notified, no? Click that notification bell. And then share, then that's it, and then so that whenever there is a new video that will be uploaded to my YouTube channel, you will be what you call this one, you will be notified. Okay, thank you very much. And stay safe, stay healthy, and God bless us all.